Hi guys, so I would take a picture of my work and then just voice over that, but I don't really know how to do that quite yet. So I'm just going to kind of video it and talk you through it. So what we're given here is that it is a triangle made out of glass and it's an equilateral triangle, and the ray is coming in. The ray that is coming in is parallel to the bottom of the triangle. So it comes in, it bends because of refraction, and then it comes out this way. So basically what I did to help me visualize this is I made a normal line, and then from there I just added up these values and then did 180 minus the sum of this, and that's how I got theta 1. And then from there, to find theta 2, because they are opposite each other, you can use Snell's law. So that's what I did here. So I plugged 30 degrees in right here, and then the 1.4 was given to us. That's just, yeah, so anyways, so I did this, and then I divided it by 1.4, and that's what this number is. And then I just took the inverse sine of that, and that's how I got 20.9. And then from there, I just added that to 90 degrees and 60 degrees, and then did 180 minus that number, which happened to be 170.9. So theta 3 is 9.075. And then we have this little triangle in the middle. Basically the same thing. I just did theta 3 plus 120, and then took that value and did 180 minus that sum. And that's how, if you look at my work right here, added it together, got that 180 minus this. And so theta 4 I have is 50.9. So since these are opposites, I went ahead and used Snell's law for this. Someone said that they solved for this, but I don't know, I don't think that's correct, because then you leave out this whole portion right here, and that's a pretty big chunk. So if I were to solve for theta 6, you probably could do that, but then you probably want to add 90 degrees. So anyways, what I did is I took theta 4, which we already solved for, and we are trying to find theta 7. So I basically did the same thing that I did way up here, the first Snell theorem or equation. And so yeah, I just plugged this in, and then I divided over here, took the inverse, and then this is what I got for theta 7, 33.677. Quick note, I have a lot more significant figures than I would, but that's just because you don't want to round too early, and this is just how I like to do it. But anyways, so yeah, I took that number, same thing like the rest of the whole problem. I took 180 minus theta 7, because this is a line, and we're trying to solve, I believe, for this whole portion. So I just subtracted 180 subtract theta 7, which gave me 146, which would make sense because, you know, it is a pretty big space. It looks big even, whoa, it looks big even on here, not drawn by hand. So yeah, guys, hopefully that helps, and hopefully I did it right. Okay, thanks.